Okay, so good evening and hello everyone. And this is week 10 of Probability and Statistics. So I'm Kamna Mishra from IIT Mandi, and the course instructor is Professor Sumesh Kumar from IIT Kharagpur. So in the last class we have covered the topic like unbiased estimator, consistent estimator, and then we have gone through uh, how to find these estimators. So basically, we have seen what is unbiased estimator, what is consistency, and then we have gone through these methods: least square method, method of movements, maximum likelihood estimation, and this is not a method. This is basically mean squared error criterion. So how if we have any estimator is given, then we see by the name itself it says mean squared error. So what we do is that just we take the estimator and then we subtract it. We take its mean, that means expectation, and then square of it and then expectation. So error and then square of error and then its mean. So then when the point it should minimize, so that one will be the minimum error. Or otherwise, if we just want to find the error, we just find that expectation. Now in maximum likelihood estimation, what we do is that if we have PDF of x1, x2 up to xn, then its MLE we try to find firstly by finding likelihood function. So likelihood function is basically given by uh, when all the xi's are independent, firstly independently distributed, and then its multiplication is the likelihood function. Sorry, the multiplication of its PDF is the likelihood function. And to find the maximum likelihood function, we can directly find it by by the way we find maximum of any function. But generally, the multiplication is uh, complex. Okay, so generally the L multiplication is complex. So what we do is that we try to find L, which is log L. Now log L we know is what, increasing function. So it is increasing function. So if we are finding the maximum of it, then at that point L will also obtain the maximum of the function. Sorry, we have also obtained the maximum of the function L. So we what we do is that we try to find del L by del theta, where theta is the parameter. Okay. So theta I, we can say, let's say theta 1 is mean, theta 2 is variance for normal distribution, or maybe theta is just for lambda for exponential or Poisson distribution. So whatsoever is this is how we find maximum likelihood estimation. And then method of movements is what we try to find. uh, we firstly write in terms of movements, and then by using method of movements we find the estimator. And least square estimation is nothing but we write xi and yi, and then we minimize the error, so it's least square. So least and estimate, we just take the square of it and then we take the least value. So these are some things about the previous class, and we were left with some questions. So firstly we will continue that questions and then we will go through today's class. Okay. So this was the first question we have left in the last class. So the given thing here is that xi be the random sample from Poisson distribution with the parameter lambda. Okay. So Poisson distribution and the parameter is what, lambda. So now we want to find uh, this is normal distribution with mean 0, and we want to find the variance of that distribution. So now what we know is that for Poisson distribution, mean and variance are same, right? So this will be lambda and variance will also be lambda. So now xi up to xn, the the variance will become lambda upon n, right? For n values, it will be lambda upon n. So now what we know is that root n x bar minus lambda we need to find, and we know is that x bar follows what? Normal lambda comma lambda upon n. So now this is just root n x bar minus lambda. So uh, mean will be what? Mean will be mean will be root n expectation of x bar minus lambda. Root n is constant. Expectation of x bar will be lambda, and then expectation of lambda will be lambda, so it will be 0. So this is given here, mean is 0, and then variance. So variance will be what? It will be root n square. Variance is a square. If we have a variance of variance of ax is a square variance of x. So it will be a square variance of x bar minus lambda, right? So this is n, and yes. So variance of x bar was lambda upon n, and then minus and lambda, I think. No, minus 0, because variance of constant is what? 0. So it will cancel out. It will come as lambda, right? So answer will be, it is mean with 0 and variance will be lambda. So this is variance of lambda will be 0 because variance of constant is 0. So this is the answer. Now the next question we have here is that we need to find the MLE. MLE means maximum likelihood estimator. So this will be also a revision kind of thing. Okay. So what is given here is that we have given the PDF and we want to find the MLE. So MLE, simply we can write is that uh, it will be, I think it will be L will be I and fxi, comma theta. So L will be what? It will be pi over I. I is 1 to up to n, and then fxi theta. So theta e to the power minus theta xi minus 1. Now theta in multiplication, so it will be theta to the power n, and then here it is multiplication, so e to the power in multiplication will be automatically in summation. So it will be minus summation theta xi minus 1. So this is our L. Now we can take the log of it. Log of L is smallest. So this will be n log theta minus summation theta xi minus 1, and then log of e is 1, right? So we don't need to write that. Now L, what we find is that we find del L by del theta, because theta here is the parameter. So it will be n upon theta minus that one will be summation xi minus 1 simply, right? Now to find the maximum, maximize or minimize. So we all always know that it can be maximum or minimum, right? So we what we do is that we put it equal to 0. So n upon theta will be summation xi minus 1. So theta will be nothing but uh, n upon summation xi minus 1. Now this is the summation over whole. So I is equal to 1 to up to n, summation 1 will be n, right? So it will be n upon summation xi minus n. Now we can divide it. So it will be 1 upon the summation xi upon n will be what? X bar, right? X bar minus n j. This will be 1, right? So this will be 1 upon x bar minus 1. So 1 upon x bar minus 1 can be MLE. Now, whether it is MLE or not, that we will find by doing the second del 2L del theta 2, right? So del 2L del theta 2 will be what? It will be minus n upon theta square. Now, theta given here is greater than 0, n is obviously greater than 0, so this will be 0. So now when del second derivative is less than 0, it maximizes the function at that point. It maximizes the function. So theta is what? Theta is 1 upon x bar minus 1. So 1 upon x bar minus 1 will be the answer. Okay. Now, one thing you also can check that whether theta is greater than 0 or not in this limit. So now all xi's are greater than 0, so x bar will also be greater than 1. So x bar will also be greater than 1, so this value is positive. So this is also satisfying in the range. So in case sometimes it happens that you have got the answer but theta is not satisfying the range, then you cannot take that theta. You will either take the minimum x1 or xn as the MLE depending on the case. So next question here is that we have xi following the distribution with PDF this. So this is, we can see that this is the exponential distribution, right? So now we want to find the unbiased estimator. So unbiased estimator, we can find like so unbiased estimator. So firstly, we can find its. What we can do is that we can find its estimator, and then we can check that whether it is the unbiased estimator or if we manipulate it, then can we get unbiased estimator. Manipulation means, let's say you have x bar, you have found x bar as the estimator, okay, but it is not the unbiased one, but x bar by 2 is the unbiased one. So what we say is that x bar is by 2, so we have manipulated by 1 by 2 to find the unbiased estimation estimator. So this is also one method we try to find unbiased estimator. Okay, so now to find just one estimator, okay, what we can do is that we can find uh, the estimator by using any of the method. Okay, yes. Yeah. So now what we can do is that we can use any of the method like MLE or least square estimation or method of movements. What we can do is just we can find an estimator and then we can see whether it is unbiased one or not. If not, then we can try to find the unbiased estimator from that also, right? Okay. So here we can clearly see that x follows exponential and its parameter is lambda, right? So now if we find the log likelihood, and if we find the log likelihood function log L, so firstly we should write L, I think. So it will be lambda to the power n e to the power minus summation lambda xi, right? So log L will be n log lambda minus summation lambda xi, right? So this is a small l. So del L upon del lambda will be what? It will be n upon lambda minus summation xi, right? Now we what we do is that we take del L upon del lambda is equal to 0 to minimize or maximize the function. So it will be n upon lambda is equal to summation xi. Then lambda will be what? N upon summation xi, and n upon summation xi is nothing but 1 upon xi. Right? Summation xi upon n will be summation x bar. Now we can take the second derivative and that one will come out as minus n upon lambda square. So n is positive, lambda positive is given here. So that value will be negative. Now this value is negative. So this is an MLE, maximum likelihood estimator. So this is what we have found, that this is an unbiased estimator. Now, now what we do is that we take it as lambda cap, and then from here we will find an estimator which will be unbiased one. Okay. So it is nothing but uh, n upon y we are taking, and we are taking y is equal to summation xi. So if in case you remember this, what we have found in the last class is that if x1 x2 up to xn are following exponential distribution, then its summation, if we take is variable y, then it follows the gamma distribution. So it follows the gamma distribution, okay, and it will be gamma n comma lambda, right? So gamma n comma lambda, and now if this expectation is equal to the lambda is equal to the real parameter, then what we say is that this lambda cap is the unbiased estimator, right? And if not, then we find that what is the multiplication we are getting in terms of lambda. So if we are getting a number, let's say 2 3, or if we are getting anything in terms of n, then we can find the unbiased estimator from here. But if we are getting something like lambda square, then we cannot get, right, its estimator, or something like uh, let's say we are getting in terms of lambda square plus lambda, okay, a polynomial in terms of lambda, then it's not, it will not be easy to get the unbiased one from there. So now what we do is that we just find its expectation. We have one estimator, we will find its expectation, because unbiased estimator is what? Unbiased estimator is if we are doing any estimator, you can take lambda cap or t anything, then its expectation needs to be equal to lambda, right? So we are checking whether its expectation is equal to lambda or any multiplication of lambda. So now for that we will find this expectation. So this expectation will be what? It will be 0 to infinity n upon y, x greater than or equal to 0. That's why we are taking 0. So y will also be y is summation of xi, so it will also be 0 greater than 0. So it will, okay, so it will be n upon y, and then it is following the gamma distribution, so it will be lambda to the power n gamma n y to the power n minus 1 e to the power minus lambda y dy, right? So now what we have is that 0 to infinity n gamma n is nothing but n minus 1 factorial. If so, because n is integer here, we know that, so it will be n upon n minus, no, it will be n minus 1. Just gamma n times gamma n minus 1. It's okay. Okay, so we are just putting it right this. I just forgot this, so we'll check it later. Now we have lambda to the power n. These all things are constant, and then it will be n minus 1, and then will be e to the power minus lambda by dy. So now we know this is gamma function. So it will be t minus 1 e to the power minus t, and this is a, so it will go on the denominator kind of. Or what you can do is that you can take lambda y is equal to t, and then you can solve it, right? So it will be n lambda to the power n gamma n gamma n times, and then this will be n minus 1, so it will be gamma n minus 1, and then divided by lambda to the power n minus 1, right? So yeah, so gamma n is n gamma n minus 1. Okay, so what we left with 1 upon lambda. Okay, so sorry, we left with lambda to the power n minus n plus 1, so it will be lambda, not 1 upon lambda, and it will be n gamma n minus 1 divided by n minus 1 gamma n minus 1. So we will left with n upon n minus 1 times lambda, expectation of lambda cap. Now, as this is nothing but a number, so if for any value of n, this is a number, so what we can write is that expectation of n minus 1 upon n lambda cap is lambda. So this is basically the unbiased estimator. So lambda cap itself is not unbiased estimator, but we have found something in terms of this. So it is sometimes very difficult to find the unbiased estimator on your own. Like, how do you find the estimator which is unbiased without any method? So we basically do simple any of the method, and MLE is the most commonly used method among all of them. So now we have found this. So this is the unbiased estimator. So lambda cap was nothing but lambda cap given here was 1 upon x bar. So n minus 1 upon n x bar. So n minus 1 upon n x bar is unbiased estimator. So this one will be the answer, right? Okay. So now the last question here is that which among the following is not a consistent estimator of sigma square? Okay. So if you have gone through the classes, you must know that s square is the consistent estimator of sigma square, right? So s square is consistent estimator. Now you need to remember is that s square is consistent when n tends to infinity. So basically we take n tends to infinity in that case. So if we are getting that as n square, s square, when n tends to infinity, that one will be the consistent one. So if you take n minus 1 divided by n s square, and then you take limit n tends to infinity, it will be nothing but limit n tends to infinity. So n will be cancelled out for the first one. It will be 1 minus 1 upon n. So 1 upon n will go to 0. 1 will be s square. So it will be s square. So as n tends to infinity, this is also going to s square. So this will also be the consistent estimator, right? Now same for the n plus n upon 1 s square. Now for the last one, what will happen is that limit n tends to infinity s square upon n. As n tends to infinity, it doesn't matter how big the variance is, it goes to 0. So this will not be the consistent estimator. So this will be the right answer for this question. So this is all about the last class we had, and now for the today's class we will solve the questions basically from the finding this variance, which we also called uh, u m v u. So what its meaning is that uniformly minimum variance biased estimate, right? So in the last class we have gone through the unbiased estimator and the consistent estimator. Now estimator or t, what we say is that t is static statistics. So uh, T is statistics or estimator, so whatsoever you want to say. So that one needs to be unbiased, consistent, and the other two was sufficient and complete. So these are nothing but the kind of characteristic which a estimator either satisfy or not satisfy, and on the basis of that, we say what is good estimator for our data, right? So if one estimator is just unbiased one and the second estimator is unbiased and consistent also, then we take the second estimator, of course. because it is following the more properties, and it is like more close to the real estimator, and that's why we basically do all these things. We basically find all these properties whether it is satisfying or not. So the more it's satisfied, the more better is the estimator kind of thing. So now we have some methods. So in the lectures you already have all these methods, but then just so that we can solve the uh, problems for today, so this is just a reminder. So first is method of lower bound. So these are the method of finding this uniformly minimum variance unbiased estimator. So generally we say UMUAV, sorry UMVUA. So this is nothing but the variance of delta is greater than or equal to 1 upon n I theta, and this is Kramer-Rao lower bound. So I theta, I'll tell you how do we find it. And the second one is that Rao Blackman layman shift approach. Now this is Rao Blackman approach, right? So these are basically two approaches. So now, if I say in terms of what is sufficient parameter, sorry, what is sufficient estimator? So sufficient one, as you always have t as a statistic. So we say t is sufficient if the conditional distribution if the conditional distribution, let's say you have the random sample of x1 up to xn, and these are following some kind of distribution, okay? So they are coming from the population. Let's say we say p theta, and theta belongs to this h. So that means, let's say that it is coming from a population. P theta basically means it is coming from a parameter. So basically, it is coming from a parameter, and this parameter is p theta. So let's say it's coming from exponential distribution. So theta is nothing but the lambda. Okay. So then, if we take the conditional distribution, x1 is equal to x1 up to xn is equal to xn, right? Divided by t is equal to t, right? Then we say this is independent of theta if conditional distribution this is independent of theta for almost d. So this need to be independent of theta for almost d. So basically this needs to be independent of theta. So the probability, if we are finding the probability, if we are finding the conditional probability in terms of this, and t is nothing but t is summation xi, right? So we are finding the conditional distribution what x1 x2 up to xn divided by summation of xi. So if this is independent of theta for almost all t, t is equal to t, okay, for almost all t here. So then we say that this is the sufficient estimator. Now, to write it in the simpler form and all, you can write it like you can just take it x1 up to xn minus 1, and then xn you can take like as t minus. So t is nothing but x summation xi up to n. So you can take xn is equal to t minus summation xi up to n minus 1. So that you can use in terms of xn. And then there is a theorem which we use generally to find whether some operator is uh, sufficient or not, some estimator is sufficient or not, and this we call as Riemann factorization theorem. So this is we have done, like we know how to do this, so we know how to do. If we have PDF given, then we can simply find this uh, likelihood function, and then if we can write this likelihood function in terms of g t x bar comma theta and hx, then we say that this t x bar is sufficient. What it means is that if we have the likelihood function in terms of two function, okay, in terms of two function where one function is dependent on theta, that's no problem, but there is another function which is independent of theta. Okay, so if we can find this in terms, then we can directly say from there only that tx bar is sufficient, because the sorry because this is the like another way to find the sufficient one, whether it is following the property or not for sufficient, right? Now the next thing is that completeness, right? So completeness is that let x is coming from population with parameter theta, which is like theta is 1. Yes. So now we say this is complete if for any function g, e theta of gx is equal to 0. Expectation of gx is equal to 0 means what? The probability of gx is equal to 0 is 1, right? So if it is following with this, what it is saying that expectation is 0, and then probability that this function is 0 is equal to 1. That means it's if expectation is 0, so basically expectation is 0 when the function itself is 0. So what is happen is that xfx, we take xfx dx. So if we are taking gx is equal to 0, so gx into f of that, like gx into pdf of that function dx will be 0, is 0, and that point of time if gx is not equal to 0, then this is not the complete. So basically we have something fx dx is equal to 0, then it this itself needs to be 0. If it is not 0, that means if expectation of any function is 0 but that function itself is not 0, then that means that is not complete. So this is basically how we define completeness. And the last one is Rao-Blackwell's theorem. So if let's say dx be unbiased for g theta, and t be a sufficient statistic. So we are taking what? We are taking h of t is equal to expectation dx given t is unbiased for g theta, and variance of theta ht will be less than or equal to variance of theta dx for all theta belongs to h. So what it is saying is that if you have one unbiased estimator for the function, and also that t is the sufficient statistic, and then we say ht as the expectation of dx given t, then it is unbiased for g theta, and the variance of ht is less than or equal to variance of dx for all the theta. What is happening here is that this one is called UMP, no, unbiased, minimum variance. Yeah. Okay. So it is unbiased. So if you have something unbiased, if you have one unbiased estimator and t is sufficient statistic, then you get it. If you make the function ht like this, then you get this as unbiased estimator, and then variance is less than or equal to variance of dx. So variance of ht is less than or equal to variance of dx for all theta belongs to h. That means it will have minimum variance also. So you have minimum variance on bias estimator. So that one is called UMUBA. Okay. So, and if T be complete and sufficient, oh sorry, so that time you have minimum variance unbiased estimator, and if it is complete also, then you have this is uniformly minimum variance unbiased estimator. So this is how you find ST. Okay, so we will move to the questions for today. So okay, so we will do the confidence interval questions later. We will firstly do the estimator questions. Sorry, that one later, and then firstly we will do the questions of unbiased estimators and all. Right. So now it is given here is that what? Uh, so given here is that x1, x2 up to xm are independently and identically distributed random samples, right? And then we want to find that which are unbiased estimator of theta and which are not. So you have given here is that x bar is equal to 1 upon m summation xi, and xm is maximum of xi. So if you have x1, it is minimum of xi. So now x bar is equal to 1 upon m summation xi. Now each xi follows u 0 theta. right? Now u0 theta. So the mean of this is mu is given by a plus b upon 2. So that one will be what? Theta upon 2, right? So if you take, now we can check like expectation of x bar. So what we are doing here is that we have two estimators, and then uh, as we have done in two three questions before, we just manipulate, we just find that which multiplication of it is the unbiased one. So for x bar we see that whether x bar or 2x bar is unbiased estimator, or no one is unbiased estimator. That can also happen. And for xn we will see whether this one or anything else is the unbiased estimator of theta, right? So expectation of x bar will, sorry, expectation of x bar will be what? 1 upon m, and the summation xi expectation, right? So now xi, all xi's were what? Uh, all xi follows this distribution u0 theta. So for all xi, mu will be what? Theta upon 2, and this is for m value, so it will be m, right? So it will be theta upon 2. Now we want to find the unbiased estimator of theta, not theta upon 2. So expectation of x bar is theta. So expectation of 2x theta upon 2. So expectation of 2x bar will be what? It will be theta. So 2x bar is unbiased estimator, right? Now, now the next one is what? Expectation of xm, right? Now to find the expectation of xm, we firstly need to find the distribution, what xm follows, because expectation of xm is what? Expectation of xm will be nothing but it will have some limit, and then so expectation of xm will be what? It will have some limit which is 0 to theta, and then xm, and then we need to find f of xm, and then it will dx, right? So f of xm, I told you in the last class how do we find that. So that you can do, so that you can do by the formula of fxi, I think, and that one is n factorial divided by n minus 1 factorial n minus r factorial fx to the power n, capital Fx to the power, I think, n minus r, and something like that. So I'm just writing it for normal distribution. Or otherwise, what you can do is that you can just go there, you can search order statistics. So here, here we go. And then you can find the order statistics for normal distribution. So for normal distribution, you have this order statistics. Now k is m here, or n, whatsoever you say. So it will be n upon n minus 1. So we will left with n, right? And then n minus n will be 0. Then u to the power n minus 1. Okay. So we will have n and u to the power n minus 1, and this is for u01. So here we have u0 comma theta, so divided by theta to the power m will also come. So it is nothing but this is equal to y. So this is capital Fx, right? Capital Fxm. So capital Fxm will be what? Everything is less than y, so it will be y upon theta to the power m, right? So now from here you can find fx, it will be m, y to the power m minus 1, and in the below it will be theta to the power m. So you can directly find from here also. Okay, I think it's not given, but then you can find from here. So capital Fx, so it will be n, it will be 1, and then it will be fx to the power n. So fx to the power, fx is what, y upon theta, so y upon theta to the power n, and this one will be 1. So this is written here, y upon theta to the power m, and a small fx is m y to the power m minus 1 divided by theta to the power m. So order statistics is generally like a little bit different, and I think like we generally don't use it, so we are not familiar with this order statistics and all. So I personally recommend you to go through all, and on your own try to find the order statistics. Okay, you have one formula, and then use the exponential distribution, Poisson distribution. Sorry, I think, yeah, I think for Poisson they, it will come in the form of summation. So go through all like exponential, normal, and for every like try to find it on your own. So if you find difficulty, you can like ask me, or you can just check in the Google. There are like plenty of sites for everything. So that you need to practice, if because it may come in your exam. So I don't know, because you cannot just go there and check. So this is our statistics, and the simple way is this: you can find fx and then capital sorry, small fx, like cdf to pdf. So now we have fx, and this is f of fxm, right? This is what we wanted to find here, fxm. So now we can find the expectation. So expectation of y, we are writing capital X, we are writing this as y. Okay. So this will be what, 0 to theta. Now the limit will all be same, because what, xm is basically the maximum of xi, right? So if it is, it can be x1, it can be x2, it can be x3, it can be anything in between 1 to up to m, which whatsoever is maximum, and then all xi's are following uniform distribution. So for all xi the limit is 0 to theta. So let's say x bracket m is equal to x4, then x4 is also following the same distribution u0 to theta, so this limit will be same, right? So it will be y and m, y to the power m minus 1 theta divided by theta to the power m, and then it will be dy, right? So it will be y to the power m basically. So m upon theta to the power m will come out, and it will be y to the power m. So y to the power m will be nothing but y to the power m plus 1 divided by m plus 1, 0 to theta, right? So it will be m upon theta to the power m. On putting 0, it will be 0. On putting theta, it will be theta to the power m plus 1 divided by m plus 1. So now it will be m upon m plus 1 theta. So now we can say expectation of m plus 1 divided by m x m is equal to theta. So this is the unbiased estimator. So m plus 1 upon m. So m plus 1 upon m. So this and this will be the answer of question. Right? If you have any confusion or anything, or if you want me to go slower or faster, you can just tell me. So, moving to the next question, we will do the confidence interval later. So, firstly, we can solve the unbiased one, and then means firstly we can solve the estimator, and then we can go through the confidence interval because it will come later. So if we leave some questions for from today's class, then we can continue it to next class, because otherwise it will be left, like estimator will be left for the three classes. That is not good. Okay, so now the next thing what we have given here is that we have given one we have given some estimators, and then we want to find which of the following statement is true. Now, the statements you can see here is that something like T1 is better than T2 or T3, T2 is better than T1, and I don't know. So for the best estimator, like better estimator, what I have said already is that you need to find you need to check the properties. Okay, so first property we always go through is unbiasedness. So if something is unbiased, let's say T1 is unbiased and T2 is biased and T3 is unbiased. So firstly, in first case we just remove the T2. So if one is unbiased, we just remove it. If all three are unbiased, then we check for the next property whether it is consistent or not. So consistent or not, or maybe whether we check that variance. So variance basically we check in the time of consistency. So variance is minimum variance. So if one has minimum variance, that means that estimator is minimum variating from the real estimator, then we will choose that one. Okay, in rather than the one which has more variance, right? So these are some obvious things, but these are the steps you need to follow. So we have three estimators. For all three, we will find the expectation firstly, and if there is any estimator which whose expectation is not matching, like not matching, sorry, whose expectation is not equal to the real expectation, which will be P, then uh, we will just remove it in the first step. Okay, so sorry. So expectation of T1 is equal to what? Expectation of X1. Now X1, we know X1 is Bernoulli distribution. So Bernoulli distribution with parameter P, so its mean will be P. So it is the unbiased one. Now expectation of T2 is 1 upon n expectation of summation xi. Now for all xi, it is p, so it will be 1 upon n, and p, it will be again p. So this is also unbiased, right? And then we can check for expectation of T3, right? So T3 is what? 2 upon n plus 1 summation I xi is expectation. So it is expectation of, so it is expectation of x1 plus 2x2 up to n xn. Now expectation of x1, expectation of x2, expectation of xn, all this is p, right? So what we can write is that we can write 2 and n plus 1, 1 plus 2 up to n, and all these have expectation p, right? Or you can do right expectation of x1 plus 2 expectation of x2, then you can put p for every xi, expectation of xi, and then you can solve it, but that one will be same, right? I have just skipped one part, I have just skipped one step. So this is 2n plus 1, and this will be what? N plus 1 by 2. This is the summation 1 to up to n. So this will be cancelled out, is equal to p. So all three are unbiased. So first, second, third, all three are unbiased. Now we need to find the variance whose whatsoever, if all have variance same, then will we will need some other technique to find which one is better. Right? So variance of T1 will be what? Variance of x1. Now x1 is following what? Bernoulli. So its variance is PQ. Right? Now variance of T2 is what? Variance of 1 upon n summation xi I 1 to up to n. So 1 upon n will come out 1 upon n square, and this is pq, and this is times n for all n. This is pq, so it will be pq upon n, right? So ultimately pq upon n is the variance of t2. Now variance of t3 is what? Variance of 2 upon nn plus 1 summation I xi. So again, for all xi, variance is pq. So firstly, this will come out as 4 n n plus 1 whole square, right? So variance of summation I xi. So it will be 4 n square n plus 1 whole square. Now it will be variance of I xi means what? Variance of x1 plus variance of x1 plus 2x2 up to nxn. Now variance of 2x2 will be, so it will be variance of x1 plus this will be 4 variance of x2, because in the term of variance it will be a square variance of x up to n square variance of xn, and variance of all xi's are what? pq. So it will be 4 upon n square n 1 square. Solve the problem on confidence. Yeah, I'll solve it later, because firstly, uh, in the questions we have solved the problems of estimators, and then we can go to the confidence interval. Is it like something urgent? You can write in the message. Okay, so that one will be uh, 1 square plus 2 square up to n square, right? So its multiplication is nothing but nn plus 1 to n plus 1 divided by 6, and then variance of this will be pq, right? So this will be 2 by 3, and then n will be cancel out, 1 n plus 1 will be cancel out. So in the below we have okay, above we have 2 2 n plus 1, I think, and here we have 3, yeah, n plus 1, and 3 and n plus 1 we can write pq upon n, right? So if n is greater than 1, then it's obvious is that variance of t2 will be less than variance of t1, so t2 is better. Now in between t2 and t3 we need to find which one is better. So what we can do is that it will be 4n plus 2 divided by 3n plus 3 pq upon n. Right? So now we can take n upon, sorry, 4 plus 2 upon n and 3 plus 3 upon n. So now from here you can see as n tends to infinity, it will be 4 upon 3 and this is t2. So 4 upon 3 is greater than 1, right? So variance of t3 is greater than variance of t2. So t2 is the best one, right? So from here we can say t2 is better than t1 and t3. So now in the last question itself, we need to find the sufficient statistics. So sufficient statistic, I have told you, just told you that how we can find it. Okay, so sufficient statistics. After that, we can do some questions of confidence interval, and then maybe we can continue this estimator also, in case you are like more comfortable with this. So if so that one is a sufficient statistic. So sufficient statistic, I've told you what we do is that we can find the likelihood function and then we can check that whether we can write that in terms of g x I theta into ht or not. So firstly we can find fxi comma theta is p here, uh, and then that one is Bernoulli, so it will be I to 1 to up to n. It will be p to the power xi 1 minus p to the power 1 minus xi, right? So now we can write it as I is equal to 1 to up to, oh sorry. So when we multiply p to the power xi x into p to the power x2, all will go in the summation, right? So it will be p to the power summation xi. It will be 1 minus p to the power uh, summation of 1 for n terms will be n, and then this will be summation of xi. So now this is 1 minus p to the power minus summation of xi, so power in minus, it will go down in denominator summation xi and then 1 minus p to the power n. So now you can see this is what g, x, x and theta, right? But there is no part, right? So then we can say this summation xi is sufficient. Okay, so there are not many questions on estimator also, so we can start with, let's say, confidence interval. So confidence interval is what, till now what we are doing is that we are finding one thing, we are finding one, we have found like one point estimator. These all are called point estimator for your known information, and this is interval estimation. So interval estimation is nothing but like we are just saying that okay, I just don't want the exact information, I want it within some limit, okay, so within some error, you can say. So this is what we say is that interval. Okay, so first question given here is that 9 peppers are baked at two different temperatures, 90 degrees Celsius and 100 degrees Celsius, to examine the impact of temperature on the weights in gram. Okay, so most probably like there is weight change, there can be different reason for the weight change. It can be because of moisture, so if we are heating on the high temperature then it may change, or there can be some other reasons, okay, so that we don't need to know. So basically, we have two temperatures and weights are different in those temperatures. So we want to find the 95% confidence interval on the in means. Difference in means, assuming that the measurements in two columns follow the independent ordinal distribution. Now, I like I just need to tell you that there are like many cases. Okay, so when you go to the interval estimation, I think estimation 5 lecture from that, if you will go through those lectures, then there are a lot many cases like your variance is known, or sometimes your variance is unknown, your mean is known, and then like there are different things. So your variance is known and equal to population variance, and your variance is unknown, so there can be different things. Okay, so on the basis of that, you need to see which tests you are using. So generally, if you have n samples greater than 30, so we use the z test. If you have this number of sample is less than 30, so as we can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. I think there are 9 samples only. So that time we use t-test. And then for t-test, we need to find the degree of freedom. So degree of freedom new is different. Okay. So if we have just one sample, like one sample, if you have, sorry, like you have given just for 90 degrees Celsius, uh, that means from one distribution only that you can say. So that time new is n minus 1. Okay, so if you have 10 samples, new is degree of freedom is 9. So that time you find the t table, you check the t table at that point of time, and then you need to see that the confidence interval, whether it is two-sided or one-sided. So there are like a lot many things that can change your result. Okay, and that can lead to you to wrong results also. So that is very important to understand what is given here in the time of testing of hypothesis. So firstly, you need to go through the all the slides like Sir has taught. So and then just write it on the paper, because you will not be able to remember everything. So when to use which kind of like formula, that is very important here, and that is the only thing important here. Actually, you don't need to understand the distribution kind of thing, you don't need to do the differentiation, integration, anything. You just need to put the exact formula what is needed there. So now what we can see here is that we do not have any information about the population. The population variance is not given here. So we have the sample variance. Okay, so this will come in the estimation 6 lecture, I think, and the third case. So sigma 1 square and sigma 2 is square. This is unknown, right? And then we have t statistics, we have new statistics. So firstly, we want to find it in difference in means. So we need to find the difference firstly. Sorry, we need to find the difference in mean. So we need to find the difference in mean. So first one, so for mean, for the first one, so let's say x1 bar and x2 bar. So I have done this already so that it can save my time. But it for you, you just go through the questions and you need to solve it on your own, right? So it is 9.28 and x2 bar is 7.84. Okay. Now S1 is square. S1 is square is sample variance of first. So X1 we are taking basically at 90 degrees Celsius, and this we are taking basically at 100 degrees Celsius. So S1 is square is 3.71 and S2 is square is 2.16, and then n1 is equal to n2, which is number of the samples. So this is 9. We have just seen this is 9, this is 9. Okay, now capital S, capital S is what? S1 is square divided by N1 plus S2 is square divided by N2, right? So it N1 and N2 are same. This is 9, so under root will be 3, and above you will have 3.71 square and then 2.16 square. Okay, so it almost came as 1.43, right? Now, the most important thing here is that how do we find nu? So, nu is the degree of freedom at which we check the t table. Okay, because here number of sample is what? 9. So, 9 is obviously less than 30. So, whenever it's less than 30, we use the t statistic. Okay. So, the confidence interval will be what? It will be x1 bar minus x2 bar minus or you can write just plus minus, so minus will be in the left side, s times, sorry, s times this uh, t. Okay, and then t at 0.025 and then that degree of freedom. So we have 95% confidence interval. We have not given anything like it is greater than or less than. Then we take uh, 5%, and then this is written as basically formula is that x bar minus y bar plus minus s times t, this alpha upon 2 comma nu. So alpha is what, if you have confidence interval 95%, your alpha will be 0.05, so alpha upon 2 will be 0.025. Now nu in this case is given as s1 is square upon uh, n1 plus s2 square upon n2 whole square divided by s1 to the power 4 n1 square n1 minus 1 plus s2 to the power 4 n2 square n2 minus 1. So that, okay, that you need to calculate. You need to remember this formula and then you need to calculate. So nu I have also calculated. So nu will come as 12.86, which is almost 30, right? So what we do is that t 0.025, and then we check the value at degree of freedom 30. So all you need to do is that you need to go through the table, t table, right? It's happening. Okay, t table, and you need to go through this 13, right? And then in that 13, t 0.2025, this is 2.160, right? So 2 point, yeah, 160, right? So 2.160 will be t. So now you can put all these values here and then you can find the interval, right? So let's just do some more questions like this. Okay. What is given here is that a group of 10 patients have mean weight to 230 pounds, and the sample standard deviation is given as 20 pounds. Then what is the confidence interval? So you have here one a sample, one sample like from one group it is given, right? In the above question we have two groups were given, so here we have one group is given and the sample size is 10. 10 is less than 30, So we will use t distribution, t table, and then uh, the degree of freedom. If you have just sample from one population only, then the degree of freedom is nothing but n minus 1, right? So t statistics we will use, right? So it will be so confidence interval will be what? It will be 230 minus, that one is if you have only one sample, then it is what, not generally s square upon root n, right? So sigma is square upon root n, as we have seen in the samples, that if you have 10 samples, it will be sigma square upon root n. So it will be 20 upon root n. So it will be plus minus, so minus plus basically, so minus, and then that one will be plus. So this, and then you have t uh, 0.025, and degree of freedom here is that n is 10, so new here will be 9, right? So like 9. So now need to go, so here 9, and then 9 degree of freedom, this is 2.262, right? So that one is 2.262. You can write here 10 or 230 plus minus 20 divided by root 10, and then 2.262. So now you can solve this. Right. Now the next question here is what? For a normal population with known standard deviation, what is the confidence interval for this? Right. So you have given. So what we do is generally we find normal distribution, normal standard normal variate. And how do we find that? We just take x bar minus mu sigma upon root n, right? And then if we have found this, then this will follow normal 0 1, and then normal 0 1 we know, we can then go through the z table, and then we can find its probability or its confidence interval, whatsoever you want to say. So this is right. So this, what we can do is that we can write x bar, we can subtract like mu minus x bar will be 2.5 sig and then minus 2.5, and then 0.25, right? That one will be mu minus x bar, and then it will be sigma upon root n, right? Okay, so that one is in minus 2.5 to 2.5. So x bar minus mu upon sigma upon root n, that one will also be minus 2.5 to 2.5, because what we do is that we do the multiplication with the minus, then sign will change, so it will be minus 2.5 greater than, will be greater than, will be 0.25, right? Okay. So now This is what? This is normal standard variate. So this is set at 0.25 minus z at minus 0.5. So now we can go through the z table. So we have the negative table. So from the negative also we can find. So 0.25. It is 0.25401 is given. So minus 0.401 and 29. So we can write 3. So this we can write it as 1 minus z minus 0.25, and this is already z minus 2.25, so that we can multiply by 2, right? So this is starting from zero point 0.5. Okay, so then we will subtract from 0.5. So 40, what was the thing, 4013. So that one will be 1 minus 0.4013 and multiply by 2, right? So it will be 1 minus 4013 times 2, 0.1974. So 0.1974 will be the answer. Okay, cool. So this is the answer. Now, the next, as you can see, that there is the question here is that independent random variable of size n1 and n2 and when n2 are given, and then we want to find the confidence interval for this. Now, if you may remember, we have done this, like we have not done this, but we have seen that when you have sigma 1 square divided by sigma 2 square, anything like this, then this will follow F statistics, right? So F statistics with the degree of freedom, like if you have S2 square in the above, then the degree of freedom that will be 14 comma 9, right? So now we need to find the 90% confidence interval for this. So uh, it will be firstly F with 14 comma 9, and then uh, it will be alpha by 2, right? To F 1 minus alpha by 2 and then 14 comma 9. Now I think I have said that also, that if you have, you need to find this f of 1 minus alpha by 2 14 comma 9, then it is nothing but 1 upon f alpha by 2 14 comma 9. Okay, so if you have found this, you have found this also. So all left is that we need to find this, and then the interval is, since you have you need to find the confidence interval for this, and given here is that s1 is square and s2 is square. So for sigma 2 square divided by sigma 1 square, we will have s2 square divided by s1 square f from 1 my just a minute, I think it is from, yeah, it is from 1 minus alpha by 2. So this is 14 and 9 is coming from n1 minus 1 n2 minus 1. Okay, so 14 comma 9 comma s2 square divided by s1 square, f at alpha by 2, 14 comma 9, right? Now s2 square, s1 square we know, and then all we need is that f table. So then we can go through the f table. Okay. So you have 14 comma 9, right? So this one is v1. So it's given as 12, and then 13, 14 is not given, so we can take some mid value kind of thing, right? So 14 comma 9. So this one is 14 and then 9. So the difference you can see is that actually it is very 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 less, and that's why we the table is not given. I'm so sorry for the sound. So the table is not given for like 12, 13, because it is given up to 40. It is very uh, complex to give all the values. So it will be something like 3.0. Like it is 14, so it will be nearby 15. So it will be 3.02. We can take, like, right. So let's say this one will be 3.02. This one will be 3.02. Alpha by 2, 14 comma 9. This one is 3.02. So f1 minus alpha by 2 is 1 minus alpha by 2, 14 comma 9 will be nothing but 1 divided by 3.02, right? So 1 divided by 3.02 by 3.02 is 0.33, something like that, right? 0.33. So now you have s2 square. S2 square is what? 29.2 divided by 25.7. So 29.2 divided by 25.7 times 0.33, comma 29.2 divided by 25.7 times 3.02, right? So this one is your what to say, interval. So then we can find 29 by 2 divided by 25.7 multiplied by 0.33. So this is coming as 0.37 something. So then you can see which one. Seven, 0.02. Yeah, so 0.33, and then you can multiply 29.2 divided by 25.7 by 3.02. So this is, the next one is 3.43 or something. So this is 3.43. So 3.437 is given in here. So first one is this, right? Now the next question. The next question is same as we have done before. Here in the first question, you have the difference of mean, right? So you have the difference, mean difference between bottom and the surface water, and then you need to find the confidence interval. So it is basically same. If you will do it on your own, that will be much better. So that you can do, I think. Okay. Okay. Just- Okay, yeah, sorry. So I'm so sorry for the confusion. This question is a little bit different. So this is mean difference between bottom and surface water, and this question was difference in means, right? So difference in means, that means x1 bar minus x2 bar. And in this question, you have mean difference between this. That means you need to find the difference firstly. Okay, so this will not come as two samples. This will come as one sample only. Sorry, this is not coming from the two population. This will come at last from the one, because we are taking the difference one. So here the things will go like this. Firstly, you do the difference. So the difference is what, point 1, and then here it will be point 0, I think 2, and then 16, 8, 28, and then point 057, and point 581 minus 382, so it will be 189, and then difference will be 0.184. Next one, it will be 373, and then point 2 456, so it will be 0.173, and the last one is 0.071. Okay, so these are the differences. So in the first one we have difference in means, and here we have mean difference confidence interval. So firstly we have found D, so this is our sample. Now we find its mean. Okay, so its mean we will find, and then we can find its standard deviation. And is what you have given, 1 2 3 4 5 6 7 8 samples, 8 samples, and then the interval will be uh, the mean plus minus standard deviation divided by root n times the t statistic at alpha, alpha by 2 comma sample is 8, so degree of freedom will be 7. So this question is basically like uh, this one we have solved, right? So you have mean, you have a standard deviation, and then you have n, and you have t value. So you can put all this value and you can get the result, right? So this you can solve on your own. You can find the mean, you can find the standard deviation. You can just put all these value, go through the detail. Still, in case you have any issues in solving any of these problem, you can just ask me in the next class. Okay, so this is, I'm not doing the calculation all the time, because it, firstly it will take a lot of time, and then secondly you also need to practice, because once you get the answer you will not practice. This is generally what happens. Okay, now the next question is what? A farmer weighs 11 randomly chosen pumpkins from his farm and obtain the weights in lbs, right? And then, so till now we have done one maximum for the mean, and then we have done for the uh, ratio of the variance, and then this question is about find the confidence interval for population variance. Okay, so we are not finding the confidence interval for mean, we are finding the population confidence interval for the population variance sigma square. So this is given here. Okay, so now uh, in this part, what we do is that we use the chi-square statistics. Why do we use it? Just tell you. So, uh, if you go through the slides, confidence interval for sigma is square in estimation fifth, I think, in estimation fifth lecture, then you will understand this part actually. And then there is also similar question also for this. So here we don't know the mean, like mean of population, and we don't know the sigma square of population also. So we use the chi-square statistic, and the confidence interval given in that time is n s square divided by, like if you have here 95% confidence interval, so that is chi-square alpha by 2, so it will be 0.05 n minus 1, so n minus 1 will be 10 2 under root n s square divided by chi-square, and this is 0.05, sorry, this is 0.025, this will be 0.975 comma 10, right? So s square we need to find here. So s square n is equal to 11 given s square you need to find, so that you can find, I'm writing the answer directly. So s square is 7.66, right? And then chi is square. So for chi-square distribution, you need to go through the chi-square tables, and we need to find the chi-square at 10, right? Degree 10. So firstly, we will go through the degree 10, and then I think I have written this also. Okay. So firstly, you need to go through the degree 10, and then you have 10's 0.975, so it will be 3.247, right? So this is 3 point, sorry, this one is 3.247, and uh, degree was 10, and then 0.025, it's 20.483, right? So this is 20.483, right? So these are the chi-square values at this point, now you can put all these values, and then you can solve it. Like, okay, so this question we have solved already, and this is we have solved. This is for a statistic. This is for statistics, and this is for mean square, like we have done. So you can do it. This is for the standard deviation measurement. Okay, so this one was actually this will not come here. This, let me just, this this is n minus one, n minus one. So this is the thing I have written, like root 1, this one for the standard deviation. For variance, this will be the thing. And for standard deviation, just root of this, comma root of this will come. Okay. So here we need to find for the variance. So for variance, you will take n minus 1 s square chi square and plus 1 s square chi square. And for standard deviation, you will take the square root of this. That's it. Like standard deviation is nothing but the square root of variance, right? So like in this question, we need to find for the standard deviation. So here it will be under root 30 and then multiply by, and standard deviation is given zero point 0.4, and then the chi-square statistics we have just found there. We have just written there. It is, sorry, it must be here. It is 20.4833, 3.247. So 20.283, 0.2843, and it will be 30 times 0.4 divided by 3.247. I think just so this will be the confidence interval for standard deviation, right? So here you have given a standard deviation. So we are finding the confidence interval for a standard deviation. Uh, Now the next question is again the difference of population mean, assuming the unknown population variance are equal. So this is what we have done already, I think, in the first question. So this is, so here, I think here, yeah, here we have difference in means, and you have the first mean, second mean. So here you don't need to calculate, you have given everything here. So x1 bar, x2 bar is given, s1 square, s2 square is given, and unknown population variance are equal, this is also given. So now when population variance are unknown, uh, but they are equal, right? So sigma square, sigma square, no? Yes. So in that case, you need to go through the estimation of lecture 6, and then you can see that here when sigma square is known, okay, so sorry, unknown, so sigma 1 square is sigma 2 square, this is given. Okay. I think this will come under this question, yes. Then the new changes to m plus 1 n minus 2. So m plus n minus 2. So here you don't need to find the new in that kind of thing, because here population variance are equal. Okay, unknown population variance are equal. This is given. So here it will be 10 plus 15 minus 2. So it will be 15, 10, 25 minus 2, right? 23. So here you have new is given, x1 bar, x2 bar, all the other things are given already. So that one was just different in this question, so that you can find it. Okay. So next question is given here is that a random sample of size 50 has variance 4 and the maximum error in estimating 95%. So maximum error will be what? N is 50. So n is 50 means we have n greater than 30, we can use the z statistics also. So sigma square is 4. So sigma is nothing but 2, right? So it will be, okay, just sigma upon root n. So sigma square upon n, fine. That one will be 4 upon root 50. That one will be divided by root 50. So that one is 0.565. So if you have sample of size 50 and you have not given anything, like literally anything, then sample will variate from the uh, variance itself, right? So the maximum error it can happen is that if you have mean here and this is the variance, so maximum error can happen is this error. So this one will be answer. So the around value we can take 0.5, right? So now we are left with these questions. Okay. So we will do one or two questions and then we will end the class. Okay. So given here is that x1 up to xn be the random sample from the Poisson distribution, and then we need to find the complete and sufficient statistic for this family of distribution. So sufficient we can find directly. Yes. So uh, it will be, we will find summation f x I lambda. So f x I lambda will be what? I lambda e to the power minus lambda xi, right? So it will be nothing but lambda to the power n e to the power minus lambda xi, right? So this is gxi theta and this is just h. So then we can say that summation xi, we can take lambda outside. So summation xi is sufficient statistic. So this is the answer for like, and the complete one we need to check also. So for the complete one, what is the thing is that, so for completeness, yeah, you want to say something? Actually, I can't hear you, so it will be better if you write. Okay, so for completeness, you check basically e theta z x, but since you have only one option given here, you can just directly take this as the, uh, where was I? Okay, we have done this one, and this one. So summation xi will be the complete and sufficient. Okay. Okay, if in F table, what is the 90% confidence interval value? Confidence level value. Okay. So you need to go through f, and then you need to check it here. Okay, so here it is given f distribution where alpha is equal to 0.01. So you need to remember alpha generally it is given as 0.05 and zero point 0.1. So for 90% confidence interval, you have alpha as zero point 0.1. Just basically 90% means zero point 0.9 value, right? So it is 1 minus zero point 0.9, so zero point 0.1. So if you want to go through the 90%, you can find it somewhere here. Like this is for 0.99. Okay, this is 0.01. So there must be table for that also. Yeah, see here it is given alpha is equal to zero point 0.1. If you can see that, I don't know. Yeah, is it visible? So I think it must be visible to you. So this is alpha is equal to zero point 0.1. Alpha is equal to zero point 0.1. That means 90% confidence interval. Then you can see alpha is equal to zero point 0.1, and then on the basis of this you can find. Okay. So that you need to check what is the alpha given. Okay, so here it is alpha zero point 0.9, here alpha is 0.01, that means 99% confidence interval, and here 0.05, that means it is uh, what to say, this is sorry, this one is 95%. So depending on that table you can find. Is that okay? Okay, cool. Okay, so we will just do this question, and then we will continue the questions in the next class, I think. So, what is given here is that firstly, we can find we need to know UMVUA. So, for that, we will check complete and sufficient, and then the consistent one we can check firstly. So, which of the following statement is not true? So uh, we can check the consistency firstly. Now, remember, I told you in one question, I think here, somewhere I have told you that if s square is, I think in the last class I have told you, yeah, that if s square is the consistent one, then if n tends to infinity, we take like multiple of s square, n tends to infinity, we take that is going to s square, then it is also what? This is the consistent estimator, right? So now we will see what multiplication of this one is consistent. So for xn, we need to check. So xn, uh, so pi of x is equal to 1 upon theta, 1 upon theta to the power n. Okay. Now tn we have given here as xn. So probability that this xn minus theta greater than epsilon. Now, this xn is what maximum of it, so it will be like theta minus xn. We can sorry, xn minus theta. We can write it, and then this is greater than epsilon. So we have xn less than theta minus epsilon, and then it is what? Theta minus epsilon. So probability of anything less than this is what? Fx, right? So that means f of capital X. So it will be f of theta minus epsilon. So f of theta minus epsilon, we know that fx is in that is b minus a divided by t minus a. So that will be the multiplication. So it will be, let's say for xi, it will be t minus 0 divided by theta minus 0. Okay. For t, let's say this t or x, so it will be x upon theta, right? So for all n, it will be fx whole n. It will be nothing but x to the power n divided by theta to the power n. That also we have done here, I think. Mm, maybe no, not in this question. Yes, here I think. Okay, you need to go through this. I think I have. I don't remember where I have done this question. But we have done this like just today we have done this. This will be x upon theta to the power n. So this time it is theta minus epsilon. X is theta minus epsilon. So theta minus epsilon divided by theta to the power n. Now it, as n tends to infinity, it is nothing but 1 minus epsilon upon theta to the power n. And as n tends to infinity, theta minus epsilon, and then this value goes to 0, right? This value I think goes to 1. It's probably. So xn is, now we know the xn. I think the proof, like complete proof, is given in the subclass, so that you can see. Now you know the xn is consistent. That means if we have anything which like divide in the multiplication of it and n tends to infinity goes to xn, then that one will also be consistent. So n plus 1 upon n, sorry, is square. So this will be 1 plus 1 upon n. So 1 plus 1 upon n into 1 plus 1 upon n, both goes to 1. So this one is consistent, but xn upon n will go to 0. So this is inconsistent. So we wanted to find the not true one. So this one is not true. Okay. So this is not true. Now U M U V U E and complete and sufficient. Uh, that is also given in the lecture, so you can see, or otherwise we can continue that in the next class. Okay, so I think till now we just end the class here. Okay, so thank you for joining, and I'm gonna end this.